actually one of my favorite tissues to look at because it's a very beautiful tissue with these beautiful striations. See? So as you see the beautiful striations, that's why I really love this one. So what type of tissue do you think this is? Yes. For the exam, you have to put skeletal muscle. Because if you only put skeletal, that's bones. So you have to put skeletal muscle. I will mark it wrong if you put skeletal only. And also I'll mark it wrong if you put muscle only. You need to have skeletal muscle. Okay? So this is actually a longitudinal view of skeletal muscle. Okay? And there are three types of muscle: skeletal, smooth, and cardiac. So what are the unique features of skeletal muscle? Give me one. Okay, yes. So these striations, so the dark striations are your, what do you call the dark striation? The A-band, correct. And then the lighter one in between is the I-band. Now if you look at the electron microscope, there's even more. You have your other types of HM line, etc., or Z line, but just for light microscopy, just know A and I. Okay? Now, let's look at the shape. The shape of the muscle, this is actually the muscle cell right here. This entire thing is one muscle cell. Or we can call it a myocyte. We call it a myocyte or a muscle cell. And you'll notice it's cylindrical. It's shaped like a fiber. So sometimes we call it as a muscle fiber. Okay, muscle fiber, muscle cell. It's cylindrical. Next, it's actually multinucleated. See, there's several nuclei here. And these nuclei are usually at the sides, at the periphery. Okay, so this is a peripherally placed nuclei. So features: striation, cylindrical, multinucleated, peripherally placed. And it's also non-branching. It's non-branching. Okay? So this is skeletal muscle. Very beautiful. Now, muscle is kind of arranged like a nerve. So a bundle of these muscle cells will be forming what is known as a muscle fascicle. Okay? And also they're surrounded by connective tissue. And the arrangement is similar to that of a nerve. So surrounding the entire muscle is called the epimysium. Then surrounding a muscle fiber, muscle fascicle is a perimysium. And an individual cell, which is very hard to see, this little that small one is the endo. It's the endo. So the difference is mysium instead of neuron. Okay? So that's the connective tissue there, right? So that is the longitudinal section. I think we have a cross section. Oh yeah, here's a cross section. This is a cross sectional view. So now this is a cross sectional view. Now you're not going to see the striations in the cross section. These are artifacts. These are not striations. This is the artifact because the striations are only seen in the longitudinal. So here is the cross section. So look, this is one individual muscle cell. Nucleus is at the periphery, and there's several nucleus. So this is a cross section here. Okay? Again, no striations because it's a cross sectional view. But we can see that they're kind of arranged in fascicles. Here's a fascicle here, there's a fascicle there, etc., etc. Okay? So cross-sectional view, and here, so this entire connective tissue surrounding the entire muscle will be the epi. Okay? All right. So that is the cross-sectional view, and then on here is the longitudinal view. Okay? All right. We have another slide of skeletal muscle. But this one is only hematoxylin, no eosin. So this one highlights, again, the nucleus. But I think it's best to look at it in the HNE. So these are cross-sectional views. These are cross-sectional views. All right. Let's take a look at it in high power. So here's one muscle cell or muscle fiber and the nucleus at the periphery. Here's another muscle cell fiber, nucleus at the periphery. And this is one muscle fascicle. And then we have, of course, again, the epi. Surrounding the whole thing, this is the epi. And then these are individual muscle fascicles. Here's a fascicle, here's a fascicle. So the connective tissue here would be the peri. Okay. So same arrangement as a nerve. Okay. So cross-sectional. This one is only with the hematoxylin. So you don't see the pink, that's the eosin. Alright. So where do you find skeletal muscle? Well, it's most of your main muscles. Your biceps, triceps, rectus abdominis. You can also find them in the tongue, okay? You can find it in the upper and middle portions of the esophagus, okay? And a few sphincters, like the external anal sphincter and the external urinary sphincter. Those are voluntary muscles. Okay? So skeletal muscle is a voluntary muscle, meaning you can control it. All right, next, let's look at the next type of tissue. All right. Let's find a nice section where it's cut longitudinally because it's a little bit cross-sectional. All right. And we'll go to high power. Okay, now we have another type of muscle. The striations here, it's still striated, but the striations are a little bit more fainter and smaller than that of skeletal. But within the striations, or actually within the cell, there's this darker looking, it looks like a striation that's even darker. That's not a striation. This represents the end of one cardiac myocyte and another cardiac muscle. This is where they attach. And that's called the what do you call it? Intercalated disc. Okay? And this intercalated disc is going to have a very important junction. Okay? Do you know what type of junction is very important here? That allows small molecules to move from one cell to the other cell? That is a gap junction or communication junction or nexus. And it's important because this allows coordinated muscle contraction of the cardiac muscles. So they need to communicate with each other. Okay? So this is your intercalated disc. So what are the features of cardiac muscle this time? It does have striations. Although they're faint, they might be hard to see, but they're still there. The striations are here. See the dark and the light? Dark, light. So it's striated. The unique feature, one, intercalated disc. Another feature is it's cylindrical like skeletal muscle, but this time it's going to be branching. Okay? Like here, you see it's branching. There's a division going down here and a division going up. So it's a branching type of muscle. Okay? It's branching. Next, the placement of the nucleus. It is usually one, although sometimes there's multiple, but usually it's one nucleus in the center of the cell. So in the center of the cardiac myocytes. Occasionally there might be multi, but usually it's one or two. So that's the cardiac, this is cardiac muscle. Okay? Intercalated disc. Intercalated disc. Okay. Branching, cylindrical, and striated. Single centrally placed nucleus. Alright. And then the last type of muscle we have, you should already be familiar with this one. Smooth muscle. We have here a portion of probably it's the small intestines. Okay. In this view, we have two, this is the muscularis propria. Okay. So you have the layer of smooth muscle here, and you also have a layer of smooth muscle here. This layer of smooth muscle, the muscle cells are seen in cross-sectional because they're going towards us and away from us. In this bottom portion, the muscles are going in a circular motion. So we see the side view. This is the side view of the muscles. This is a cross-sectional view of the muscles. And then if you remember, what do you call this structure here? Found in between the two muscular layers. Remember that? What is that structure? You don't remember this one here? Found in between the inner circular and outer longitudinal muscular layer? Don't remember your Auerbach plexus? You already forgot? That's your Auerbach plexus or your myenteric plexus. Okay? And then what was the cell you're supposed to look for that has a single prominent nucleolus? It's your ganglion cell. Okay. So let's look at the longitude. Let's look at the side view of these muscles. So for smooth muscle, they are what we call a spindle shape or fusiform shape. Okay? Meaning they're very thin and they have little pointed edges, like a spindle. Okay? There are no striations. Okay? You do not see striations in this one. Okay? No dark band or light band. Okay? And then the nucleus, it's usually just one nucleus in the center. And we describe the nucleus as a cigar shape appearance, kind of like a cigar, blunted ends. Blunted ends. So that's a side view. In the cross-sectional view, it's a little hard because you see just cross-sectional view of the muscles. Here. They're going towards us or away from us here. And the nucleus is here. So focus more on this part, that's a better one. Okay? Alright. So that is smooth muscles. Okay? Non-striated, spindle shape or fusiform shape, single nucleus. Okay. Right. We have the old slide here. So let's look at the old slide. Those were the new slides. You see the branching pattern here? So this is the branching. Here's the intercalated disc. Okay. So this is the old slide. Okay. So this is cardiac muscle. Okay. This one's nice to see the branching. You can really see the branching. Okay. Then we have another structure here. What organ do you think this is? Yeah, it's the ileum. Although there's no Peyer's patch, but the smooth muscle is here. This is the muscularis propria, where you find the smooth muscles. Okay, and it's a little staining is not so good, but yeah, the staining is not so good. Spindly, sort of, kind of hard to see, and it's kind of there's a little artifacts. It's a little cracked. So I don't think that's nice. That's smooth muscle. All right, let's go to cartilage. Oh wait, we have another slide. We have another hematoxylin. I don't know why they like the hematoxylin only. Hematoxylin only of cardiac muscle. I don't like using this hematoxylin. I think it should be best with both. Okay. But again, this highlights the nucleus. It's centrally placed. Okay. Focus with the H&E rather than just the hematoxylin. Alright, let's move to cartilage and bone. Alright, first, this one, right here. What type of tissue is this one? That's hyaline, okay? So, hyaline cartilage is going to be surrounded by this dense, irregular, collagenous connective tissue, which is known as the perichondrium. Okay, that's the perichondrium. Then the actual cartilage is in the middle portions. Okay? So let's look at the cells first. So that was scanning view. Now we are at low power. So this cell is the perichondrium, and these are the fibroblasts here, right? These are fibroblasts because it's collagen. But under here, you see different cells. These cells are a little different. Let's take a look at that. See, these are the fibroblasts up here. But these cells are different. What are these elliptical cells that are found right underneath the perichondrium? Not chondrocytes, chondroblasts. They're the younger cells. The younger cells are the chondroblasts. As they get older, they get pushed towards the center. And then they become this, chondrocytes. And you'll notice that they're in little aggregates. So we call them as isogenous aggregates or cell families. And then you'll notice that the cell, when we process the tissue, they kind of shrink and they leave this little space surrounding the cell. That's called a lacuna, singular, lacunae plural. Okay? So when it has this little space and its deeper portions, what cells do you call them now? Chondrocytes. See, here's the space. Here's the cell membrane, and then you can see the space because it kind of shrunk a little. In real life, there's no space, but it's just a process. When we process them, they shrink. And since they're not attached to adjacent cells, they don't have the desmosomes to hold them together, so they just kind of shrink like that. So it's actually an artifact. Okay? But they're still in clusters, so cell families or isogenous aggregates. This is your chondrocyte. Okay? And you'll also notice that the matrix is usually a nice dark blue, usually, depending on your staining. In this one, it's very nicely stained. And then there's no blood vessel, because cartilage is an avascular tissue. Okay? So hyaline cartilage is the most common type of cartilage that you're going to find. In this case, what organ do you think we have? Look at the lining epithelium. Although the lining epithelium is overly stained, it's too much hematoxylin. But if you look faintly, there are goblet cells. And there are cilia here. So this is the trachea. Okay, the trachea. Although the epithelium is overstained, I will admit it's too blue because you can't see the nucleus. So way too blue for me. But you can still see the goblet cells and the cilia, so you still know this is the trachea. You also find it in most joints, okay, most joints, as well as most joints in between bones, many types of bones, okay, your articular joints, okay. Except for the knee. The knee is different, and intervertebral and your pubic symphysis, they're a little different. Okay. But most other joints, like in your wrists and your elbows, they're all highly cartilage. And also, it forms the initial skeleton in the embryo. You have hyaline cartilage, which will then become replaced by bone. That's called endochondrial ossification. Okay? So that's hyaline cartilage. Next. Slide's a little dirty. Hold on. Okay. We have another tissue here. Okay, up here. Okay. So the cartilage is here. But let's look at the lining epithelium. What's the lining epithelium? Keratinized, non-keratinized? Stratified. Yes. So we notice that this is keratinized stratified squamous. There's no nucleus. So keratinized. And then we see this cartilage. What part of the body do you think this is? Notice it's a little bit more red too. A little bit more red. This is elastic cartilage. Okay. Actually, hyaline and elastic cartilage look very similar to each other. The slight difference is it might have a little bit pink or it might not be quite as blue. But the ideal method, because that's not always reliable, especially if your stain is not so good. The ideal is to use elastic staining. When you use elastic staining, you'll see these little black threads. Okay, because elastic cartilage has elastic fibers. Elastic fibers are not really seen in hyaline cartilage. That's the best difference. But here, this is H&E stain, so we don't have the elastic stain. But it's the same layout. You have the perichondrium, then you have your chondroblasts, the elliptical ones, and then you have again your chondrocytes. Same, they look identical. Slight difference, although not always. Usually it's a little bit not quite as blue. But that's not the best, because again, your staining might not be the best. The best is really elastic staining. And then the other clue, try to identify what's the organ. Because you're not going to see like hyaline cartilage in the skin. You're not going to see that. Okay? You might see hyaline cartilage in respiratory epithelium or other portions. But what part of the body do you think we're looking at? Yes, this is to be specific, it's the pinna or the auricle of the external ear. Okay? That's the part, if you notice, if you flip your ear, it recoils back into place. It's because of the elastic fibers. They recoil back. So you can flip your ear, it recoils back into place. Okay? If you notice the nose though, it's hiding, it's more firm. It's more firm. It doesn't really recoil quite as well as your ear. So the hyaline cartilage of your nose is much more firmer and stiff compared to that of elastic cartilage. Okay? So this is elastic cartilage. Where else can you find elastic cartilage? Yes, the epiglottis, which we have in the old slide actually. So here is the epiglottis. See again, it has this nice little pink hue to it, but again, that's not the best result. But let's look at the lining epithelium. In the epiglottis, although I know the staining is not so good, but please bear with me. What's the lining epithelium in the epiglottis? It's non-keratinized. So that's the difference. If it's skin, it's keratinized. If it's the epiglottis, it's non-keratinized. Okay? Non-keratinized. So this is the structure that prevents food from entering your trachea. Okay? And what's the last place to find elastic cartilage? It's the eustachian tube. Okay? So it's all E. Ear, epiglottis, and the eustachian tube. Eustachian tube. The one that regulates pressure from your inner ear to your pharynx. So that's elastic cartilage, hyaline cartilage, and then we got the next one, or the last one. This one's a little bit tricky because I don't like how it's cut. This is actually the intervertebral disc. So you see the vertebrae. This is the vertebrae here. This is actually spongy bone, which we'll talk about later. This is spongy bone with red marrow. But focus here in the center. And it's a little chopped off on my slide here, a little bit chopped off. But let's look at it. Now, in this type of tissue, if we look very carefully, there is still a lacuna. Do you see? Like this one here? Do you see there's a space? So this is not a fibroblast. This is, what cell is this? Has a lacuna. It's a chondrocyte. But you notice that the chondrocytes are not in isogenous aggregates, right? Instead, in this particular case, they're seen singly or scattered. Or sometimes they are in lines. See this line? We call them as linear isogenous aggregates. They're formed in a straight line. So they're either seen individually or in linear isogenous aggregates. And then the background, it's not quite as blue, like in hyaline cartilage, because this is a combination of cartilage together with dense collagenous connective tissue. So this is known as fibrocartilage. Okay? So make sure that you're looking at the lacuna, because you might mistake this for just dense regular or dense irregular collagenous connective tissue. But the difference is, again, the lacuna and the arrangement of the cells. They are linear isogenous aggregates, or they're single like that, individually. Okay? So this type of cartilage, fibrocartilage, is found in the intervertebral disc, as well as the the tendons are dense, regular collagenous connective tissue. So this is the intervertebral disc, the pubic symphysis, and in the knee joint, the meniscus of the knee joint. Okay. Most other joints though are hyaline cartilage, but the knee is very special. It's a weird joint. The knee is a very weird joint. Even anatomically speaking, it's weird. Okay. So this is fibrocartilage. Let's go to bone. So there's two types of bones. We have compact bone and we have spongy bone, or also known as trabecular bone. So we have a very nice slide here of bone. So what type of bone do you think we're looking at? This is compact bone. It's very solid. Okay. So what's the functional unit of compact bone? It's called an osteon. So let's look at the osteon. This ovoid structure is one osteon. Here's another osteon here. Here's another osteon here, and osteon. These are all osteons. Okay. Then in between you have the interstitial laminae. Okay. So let's look at individual osteon here. Now this is this is a stain we don't always use. I think this is the gold stain. Not always common, but it's very nice because it highlights the cells very clearly. So this is not your H&E stain. So we're looking at one individual osteon. Maybe it's too high power. Let's go back a little. Okay. So this is one osteon. What's here in the very center of this osteon? That is known as this one. It's your reversion canal or your central canal. Since compact bone is very solid, your blood vessels have to travel through these canals and these tunnels. So this is the central canal. This is where blood vessels and your nerves will go through the bone to supply nutrients to the bone. Then if you look carefully, you'll notice that there are these little rings around the central canal, and it kind of looks like the tree rings. So each individual ring is called a lamella. Okay? And then the outermost lamella is called the cement line, which separates it from adjacent osteons and also the interstitial lamella. Okay. Interstitial lamella are the ones in between. This is the interstitial lamella. Okay. Then we also have some cells. Take a look. This stain really highlights the cells. So there's a cell here. It also has a lacuna, but you can't really see it with this stain because it actually covers the whole cell and it doesn't highlight the lacuna. But it does have a lacuna. But this cell has little processes. See the little thin threads that are coming from this cell? Those are the processes. And then these processes of the cell, they actually have to burrow through the matrix. And they go through these little tunnels which are called canaliculi. Okay, those are canaliculi. So what is this cell that I'm referring to? Yes, that's the osteocytes. These cells are usually inactive. It's the osteoblasts that are the ones forming the tissue. The osteocytes are less active. Okay? So that's the osteocytes. We also have one more important structure, which we see here. You see we have this osteon here, and we have another osteon here, right? And then we see the central canal here, and there's another central canal here. But you see there's a little tunnel that's trying to connect the two central canals. What's this tunnel called? That's the Volkmann's canal, or the perforating canal. Okay? They will connect adjacent central canals. Okay? Oh, very nice osteocytes here. This one has very nice osteocytes. A little bit of the lacuna in this one. And the little processes from the osteocytes. Because it's very hard for nutrients to penetrate bone. That's why they need these processes, so they can get nutrients from the central canal. Right? That's the stained bone. We also have an old slide that's non-stained. So this is the non-stained version. So to look at this, you might have to tone down the brightness a little bit. Okay? So it's a little less brighter. But the principles are still the same. Osteon, central canal. The osteocytes are a little bit harder to see because they're not stained. So it might be hard to see. You could see the lacuna. You can see the lacuna there. Okay? Osteocytes are a little harder to find. Okay? So this is compact bone. Right? Let's go back to our spongy bone. We'll look at our spongy bone. Again, this is our intervertebral disc, but we're going to look at the sides, the actual vertebrae. So this is spongy bone. Okay? So there's two types of spongy bone with different marrows. There's spongy bone with red marrow, and then there's spongy bone with yellow marrow. What's the difference between the two? Yeah. So the red bone marrow, it's actually going to have developing red blood cells. And then yellow, what's that going to be? Fats. Okay. Now, in this one, what do you think we see? Red or yellow? Red. This is red marrow. Although yes, there is occasional fat. Okay? And that's seen here. But the predominant is red. And when we look at bone marrow biopsies, we have to assess its cellularity. So we would roughly give it a percentage, and usually as you get older, it gets a little bit more and more fatty. Okay, so you don't need to know that, but when you go to hematology, I'll ask you how to assess the cellularity and stuff. So let's take a look at. For now, let's just focus. Let's not focus on the marrow because that's for your hematology. Let's focus on the bone. So this is spongy bone. Because what they have is these bony trabeculae. Okay? These are trabeculae. Don't confuse them with the trabeculae that's your collagen that you see as a septum. This is bone tissue. But they have a shape like trabeculae. So this is the bony part here. Okay? And now if we go to high power, let's look at the cells. You'll notice that there's usually a single layer of cells. That's quite a big area. Here, this is a good area. So you'll notice there is this single layer of cells right here on the surface of the bone, on the bony trabeculae. What do you call those cells? Although you're right, they would be covered by an endosteum. But the cells itself are called so these cells that line the trabeculae are called osteoblasts. They are the young cells that are forming most of the matrix. These are the osteoblasts here. Okay? I think the high power needs to be cleaned. It's a little dirty for me. There. Let's add more light. Okay. So these are the osteoblasts. Now, as they produce matrix, they'll get trapped. And again, they'll form this lacuna. See the lacuna? Now what are these cells? Here in the middle. Osteocytes. Okay. Now there's one more cell, but I don't want to struggle trying to find it. It's a very large cell that's usually found on the surface of these bones, and it's multinucleated. Those are your osteoclasts. Okay. And don't get it confused with this cell. This cell is a megakaryocyte. That's different. It's a large cell, but it's different. The osteoclast should be here, not in the middle. That's a megakaryocyte. What's the function of a megakaryocyte? Do you know? Platelets. Good. That's platelets. But don't confuse that one. That's a megakaryocyte. But anyways, the osteoclasts are responsible for bone reabsorption. Okay? Where the osteoblasts are for bone formation. So you need the balance. Your bones are not static. They're constantly being built up and they're being broken down by the needs of your body. So it's not just static. Although when you look at a skeleton, it's static because they're already dead. But in the living person, these are actually living tissues. They're not just hanging around. They're active. Oh wait, it seems like we do have an osteoclast here. We do have it. Oh, how lucky for you guys! Right on the surface, you see this large multinucleated cell? Oh, how very lucky. We have an osteoclast. And then actually, we even see the bone reabsorption lacuna. So this is the portion of the bone that's being reabsorbed. Oh, you're very lucky. How very lucky for you guys. We found one. There's the osteoclast, and then this is the reabsorption lacuna. So anyways, wow, how very lucky. So that's the osteoclast. There's also another one here. Another osteoclast here. So, wow, very lucky. Okay. So that is your spongy bone. Next, we have to show you osteogenesis. So there are two types of osteogenesis. What are the two types of osteogenesis? Intermembranous is one, and the other one is endochondrial. So in intramembranous, what you have is you have mesenchyme. And then remember I told you that mesenchyme has the ability to transform to other different types of tissue. So from mesenchyme it goes straight to bone. That's intramembranous. Endochondrial, the word endo means inside cartilage. So you have initially a hyaline cartilage template. It's like a skeleton that's initially hyaline cartilage. And then through the inside, it will gradually be replaced by bones. And this is most commonly seen by your long bones. So this is actually endochondrial ossification. So at the end of the bone, we still see hyaline cartilage. This is hyaline cartilage, although it's that of an embryo, so it's not, the isogenous aggregates are not quite that developed. And then here in the middle part of the bone, it's actually mature. This is the real mature bone. Okay? So there's actually several layers or zones in the zone of endochondrial ossification. So let's go through all these zones. First, you have the normal hyaline cartilage for the age group. We have to consider the age group. So this is called the zone of reserve. This is the normal hyaline cartilage that you see. Okay? Next, we'll go to a little bit higher so you can appreciate it a bit more. And this is the old slide. Okay? So zone of reserve, just normal hyaline cartilage. But then as you go closer, you'll start to notice that they're starting to form columns and they're starting to line up. See? Compared to here, they're just either in their isogenous aggregates or they're scattered. But in this area, see, they're starting to stack up. Okay? They're in little rows or columns. That is now the zone, the proliferative zone. or zone of proliferation. Okay? And then the next zone, if you look, you see the cells here that are stacked up. Now compare them to the cells here. They are bigger. The cells here are large compared to the cells here. So what do you call enlargement of the cell? Hypertrophy. So this is now known as the zone of hypertrophy. That's this area. And then, if you look a little further, the matrix will start to calcify. So you'll start to see a little pink hue to the matrix here. This is early deposition of calcium. So this is now the zone of calcified cartilage. Zone of calcified cartilage. And then when you go here, now take a look. You start, I know the staining is bad. You can actually begin to see the trabeculae. Here's the trabeculae. And then they even have the osteoblast on the surface. This is now your zone of ossification, where it's already become ossified and it's already your bone. Okay? So those are your zones. So let's go back. So this zone is your reserve. And then here we're on the left side, zone of proliferation on the left. And then on the right, because they're bigger, zone of hypertrophy. And then at the very edge, you start to see the peak cartilage. And then lastly, we have the zone of ossification. That's endochondrial ossification. Okay? All right. And one last thing I forgot to mention. I'll show it to you in this. Your cartilage, also, your bones are also going to have connective tissue. So in the cartilage, it was called what was the covering of the cartilage called? Peri. In bone, it's called there's actually two. Peri. There's peri and endo. So the one on the outside of the bone, peri. So this is the periosteum here. Endo, it's a little hard to appreciate because it will be lining the same together with your osteoblast. So it's a little hard to see, but it's the collagen surrounding your osteoblast. So this is the periosteum, endosteum on the inner surface. Okay? Alright. So those are the different types of bones. Okay? Are there any questions? Any questions for the